All right, real quick setup for the law of reflection lab with mirrors and light. So the materials are shown right here. You're going to need this flat mirror. The laser is going to act like the light beam, which I'll show you how that works in a second, and then you'll need a protractor, measure a bunch of angles. So I've already done some of the setup already, but I'll show you how to go through this step. So you're going to lay your mirror flat like this, so have it facing one way on your page. On your piece of paper, you want to know where that's laying, so obviously draw a line, and that'll be where you place the mirror every single time right on it. You'll also want a dot right in the middle of that, because when using a protractor, it's not actually the edge of the protractor that you line up, it's the dot with the black lines in the middle. So that dot's important to make sure you keep putting the protractor down at the right spot. Notice the black lines line up with the line that I drew as well. And if you're spot on, all right, if I'm spot on, I should then have the normal be where 90 is. So you don't have this dashed line drawn yet, but we want to draw that. It's called the normal. It's the perpendicular with your mirror, with the boundary between the air and the mirror itself. So make a dot out at 90 degrees. All right, if you have your dot here as well, you can then flip this and then do a dashed line, which is showing you the normal to the mirror. All right, the normal is extremely important because we measure all of our angles from the normal. So we're going to shine in a bunch of light rays with the laser beam into this mirror, and the angle that they come in at is always measured from the normal. So you can see the other thing that I have set up for you are the angles that I want you to shine the laser beam in. So if you actually put the dot back on here, all right, the little hole, and line it up, okay, this should be perfectly at 90 degrees. Now, the angles we want are measured away from the normal, so it should be 15 degrees, 30 degrees, 45, 60, and 75. It won't say those on the protractor because they're measured from 90. So you could do it one of two ways. You could do 90 minus 15 is 75, or you could do 90 plus 15 is 105. But basically measure those out, and then you pretty much have your whole setup ready to go. So here's then the actual procedure. Once you get that all marked out, you're going to put the mirror back where it should be, and then you're going to take your laser beam, and it should then create this nice little beam. If it's not, spin this little knob at the end. It'll go from a point to then kind of a line, all right? But the idea is you're going to want to shine it in at specific angles. So the first one's actually 0, which is right on the normal, because again, we measure it from the normal, so 0 degrees is the normal. And you won't see a reflected ray because it actually comes back on the exact same path. When you, though, do 15 degrees, make sure it's on 15, but also very important, make sure that it hits the dot where the mirror is. You'll then see the reflected ray there. So what I would like to see you guys draw is, before you even do that, you can draw in with different color or same color, not a big deal, from 15 degrees to the mirror where your dot is. You can draw on this ray, okay, this is called the incident ray, coming in at 15 degrees. Your laser should then line up perfectly with that once you have the mirror. And then what you can do is, okay, it hits right here afterwards, so I can make a dot, and then when I remove this, I could of course complete this from where it hit the mirror, which should be right at that dot. This is not my incident ray, this is my reflected, and I can of course measure this angle right here, which we call the reflected angle, by using my protractor. Okay, you're going to do that for all of these angles, and then of course fill in the data table, and you should see a pattern. All right, good luck with this, guys.